chemical bond is a little bit difficult part. Some of you. So we are going to revise it today. Start to discuss about that. If you have missed your lesson, this is a kind of revision. I'll be giving you some of the information about the chemical bonds and we'll go on. There are some basic things that we have to understand if we are to go with the chemical bonds, and I have the lessons with me, the chemical bond. I will give you some little questions, small questions, and then proceed with the lesson. Okay, let's start to write our questions. Luckily, I reversed my Microsoft whiteboard, the old one, right? Chemical bonds. Anything you want to ask about the chemical bonds? Any doubts that I can start with that one? Anything you want to know? Yeah. Okay. My first question. Okay. What are the, should I use a black one or blue one? Which color is perfect with you?
Black is okay.
Yeah, I put a shared screen so you can see very clearly. What are the subatomic particles? Subatomic particles in an atom. What are the subatomic particles in an atom? Answer: electron,
Electrons, protons, and neutrons.
electrons, protons, and neutrons. Electrons, protons, and neutrons. Second one. Do all the atoms have same number of subatomic particles? Subatomic particles. Do all the atoms have same number of subatomic particles? Your answer?
No. No, sir.
No. Do all the atoms have the same number of subatomic particles? The answer is no. Third question. Which WHICH? Which atoms of elements have the um, stable amount of electrons. Which atoms of elements have the stable amount of electrons? The answer? The answer?
Elements of A group.
That's correct. Elements of the eighth group or noble gases. Noble gases. 4. Write two possible valence electrons. Write two possible valence electrons. Write two possible valence electrons which can be stable. Try two possible valence. Try two possible. Write two possible number of. Write two possible number of valence electrons which can be stable. Your answer. Your answer. You can't understand the question or don't know?
1 and 7.
1 and 7. Yeah, I just told you this word. Two possible number of valence electrons which can be stable. So I told you which atoms of elements have the stable amount of electrons. So your answer was elements of the 8th group. Now I'm asking now two possible number of valence electrons which can be stable. Give a guess. What's it? Your answer?
0.
Huh?
0.
Actually, I didn't hear it.
0.
0. Valence electron, the last energy level. The number of electrons at the last energy level.
2 and 8.
2 and 8 is the correct answer. 2 and 8 is the correct answer, and I agree with that. 2 and 8. 2 and 8. 2 and 8. Now I will tell you why. I will tell you why 2 and 8. 2 and 8. Now you got a little doubt. Sometimes your answer was not there because of this one. Valence electron. Valence electrons. What do you mean by valence electron? What do you mean by valence electron? Right? Valence electrons means when you arrange, like for example, X13, right? X13 indicates this is the atomic number. So you can write electronic configuration as 2, 8, 3. So the valence electrons mean the number of electrons at the last energy level. The number of electrons at the last energy level. So that's valence electron. I'm asking about the stable condition. When they are stable, no further electrons are required. In the above occasion, so if you say when 283 configuration is considered, what can be done? You have to do something for the 3. You have to do something for 3. You have put the answer. I didn't see that. Okay. Yeah, see, when 283 configure is considered, what should be done? This 3 is the problem, right? The problem is the 3. 2, 8, 3. Now, you can do 3 things. You can do 3 things for this 3. What are the 3 things that can be done? 1, remove and make it 2, 8. Remove and make it 2, 8. Or add another, how many electrons?
5.
Another 5 electrons. Add another 5 electrons. 5 electrons. Another 5 electrons and make it 2, 8, 8. Right. So what can we do then? Next one?
Sharing with another atom or atoms.
Very good. Share share 3 with another atom or atoms to make it 8. Which one is possible for this one? Which one is possible for this one?
Remove and make it.
Yeah. This one, of course, not possible, right? It is not normal condition. We have not seen it, right? Right. But remove and make it to 8, the most possible way. It is the most possible way. But what about share n? This is also possible, but not always. Share n. That's what, actually this is aluminium. You know that aluminium has that fault. Right. Now, then if the situation is considered in this way, so I told you that valence electron, we started the discussion because we got the problem with that. And we know X13, atomic number is 13, so I write 283. 3 is the valence electron, where that the whole bonding, chemical bond lesson goes on. And when they stable, no further electrons are required. So then 228 is the stable condition and no further electrons are required. When 283 configuration is considered, see, it tries to take the stable condition in like 280 or 288, right? So when share 3 electrons, share 3 electrons, it will be then 288. 288 by sharing electron, the last one. But the most possible one, aluminium, of course, that might not possible, but if you consider the configuration like this, configuration like this, 2, 8, 1. Which method is possible? Removing electrons is possible. Removing is possible. 2, 8, 2, 8, 6. Which one is possible? Taking, obtaining electrons is possible. Obtaining electron is possible. 2, 8, 4. Sharing electrons is possible. Sharing electrons is possible. Right. With that basics, we are going to continue with our question, right? This one. Now, I gave you the fourth question, right? Two possible number of valence electrons which can be stable. Right. Question number 5. Question number 5. There are two types of bonds. There are two types of bonds depending on the method of completing the electrons of last energy level. What are they? What are they? There are two types of bonds depending on the method of completing the electrons of last energy level. What are they? 1, 2.
Ionic bond and covalent.
Yep. Ionic bond, covalent bond. Ionic bond. covalent, covalent bonds. Ionic bonds and covalent bonds. Ionic bonds and covalent bonds. How are ionic bonds made? How are ionic bonds made? The answer? By
exchanging electrons.
exchanging electrons. By exchanging electrons. By exchanging electrons. 7. Right. The groups of the periodic table which have atoms for sharing electron. Oh, exchanging electrons. Exchanging electrons. For exchanging electrons. Exchanging electrons. Write the groups, GROUPS. Write the groups of the periodic table, periodic table, which have atoms for exchanging electrons. Yep.
first, second, third.
Yeah, no, now when exchanging, there should be two parties. There should be two parties, right? I mean, donor and receiver. So the donor and receiver, donors, D-O-N, donors, N-A-R, my spelling hard. Recipients, R-E-C-E-I, P-I-E-N-T, recipient can receive, recipients. I don't know the spelling. Donors. Yep. First, second, and third. Recipients. Kaul.
6 and 7.
6 and 7. Is there anyone who can't understand that part? Anyone who should need more information about this? Try the groups of the periodic table which have atoms for exchanging electrons. Donors, 1, 2, 3. Recipients, 6 and 7. කවුරුත් හිටියේද? ඒ පිළිබඳව තව විස්තර ටිකක් දැනගන්න ඕන නෑ? ඊයේ ෆිසිකල් ක්ලාස් එකට ආපු අය දැක්කා ඔබ රෙස්පොන්ඩ් කරන එක කොච්චර අවශ්‍යද කියලා නේද? අහනකොට රෙස්පොන්ඩ් කර හිටපුවාම අපි හුඟක් අසරණ වෙනවා. එතකොට අපිට ලෙසන් එක ඩිසයින් කරගන්න බැහැ. Okay, donors and recipients. Ready? Is there anyone who needs more information on this part? Okay, I myself will decide and go. If you consider the periodic table, we are dealing with the 20 elements periodic table with 20 elements. So when considered the periodic table with 20 elements, I'm just going to show you that. Hope that the rain is no more there. Electronic configuration. Yep. Trying to get one. Copy. Let's give a try. Very nice. All right. Look at here now. You have the electronic configuration of the periodic table. I think this is clear, and going to elaborate that. Right. The whole story is going to be with this. If you can see, stop sharing. Look at here. This is the periodic table of the first 20 elements. And as you can see that hydrogen is separated from this, and the blue color indicates the non-metals, and this yellow color indicates the what? Metals. So except aluminium, except this aluminium, all the metals only exchange electron. So they donate, and some of them will receive it. So exchange in electrons will be done, not sharing. But aluminium, in certain occasions, most of the time it exchange, certain occasions it share electrons, right? Now, look at here. This lithium has 1 electron, so that will be donated. Sodium has 1 electron, will be donated. Potassium has 1 electron, will be donated. Then it will receive the this 8th group or the noble gases configuration, which is just 1 below to them, 1 electrons below to them. So lithium will be having heliums 1, sodium will be having neons 1, potassium will be having the argons 1. Right. Then if it is like second group, if it is in the second group, this is first group, right? They will be exchanging or donated the 2 electrons, this one and this one. So magnesium, this one and this one. Calcium, this one and this one. So they will be making always the number 2. So I will tell you what it says, number 2. Look at here. If magnesium is going to make the bond with the 7th group 1, the bond is going to make magnesium with the 7th group 1. Count the number of electrons it needs. 1, 2, 3, 4, 5, 6, and 7. If it receives another electron here, luckily, immediately it will take the neons configuration. If this one receives another electron, and it will be having the argons configuration. So now look at here the story. Magnesium is ready to give 2 electrons. Magnesium comes with 2 electrons in its bag. So it comes with 2 electrons, magnesium. And the chlorine comes in return. Chlorines come in return with 7 electrons. 7 electrons, right? So the marriage will not take place properly because magnesium has 2. Chlorine needs only 1. So what will be happening then? With approval or not, chlorine will be having another partner to take this magnesium's 2 electrons. So another chlorine is coming to take magnesium's the other electron, 7 electrons. So there are 2 chlorines to get this magnesium's 2 electron. And then what happened? Magnesium makes the bond with 2 chlorine atoms. And then this is a type of exchanging process. Magnesium gives that electron to chlorine, and then chlorine receive them, and magnesium chloride is made. So it is very clear, I told you, magnesium goes with the 2. So the possible bond is MgCl2. The possible bond is MgCl2. And a magnesium, if it is to make with the fluorine, it is the same, MgF2, right? Now let's see what happens if magnesium goes with oxygen. Magnesium goes with oxygen, right? Magnesium goes with oxygen, right? Magnesium, what's it? Magnesium, here you got, magnesium is this time going with 2 electrons. Good. Magnesium going with 2 electrons. Chlorine, in other way, sorry, oxygen. Oxygen needs 1 over here, the other one over here. So very nice. So oxygen is a nice lady that requires 6 electron in her valence electron, yeah, the last energy level. So he's ready to give 2 electron. This one is in need of 2 electron. So what will happen if when the electrons are exchanged? Magnesium, 2 electrons are given to 1 oxygen. So the bond that made is magnesium oxide, Mg. Then what happened to this 2 of magnesium is equally shared with the 2 of oxygen. Now we found out that from there the bonding power, BONDING, which is referred as valency number, bonding power, valency number depends on the group number. So if it is the group 1, so the valency number is 1. If second group is considered, see that it is ready to give 2 electrons. So its bonding power is 2. And if you consider the third group, then the bonding power is 3. And if you consider the fourth one, see that it needs 4 electrons. So its bonding power is 4, right? And if you consider this one, nitrogen and phosphorus, what is its bonding power? It is 3, not 5. Sometimes it's 5, not always. Sometimes it's 5. When you go to oxygen, it requires 2 electrons, so its bonding power is 2. And if you consider the fluorine, only 1 electron is required, so its bonding power is 1. And no bonding power is here, so it's 0. And you can understand that the valency number of each group depends on the way that the possibility of exchanging or sharing electrons. Now, these numbers are going with the bonds when they are made. I'm going to explain how it happens. Imagine that the marriage is going to be with the potassium and oxygen. Potassium and oxygen. Let's see, potassium, oxygen. The very first thing that we want to tell you is that who comes first and who comes second. I mean, the one in the yellow color should come first, or the one in the left side comes first, and the ones who are second come second, except hydrogen. Hydrogen is differently behaved. Sometimes it comes first, sometimes it is in the second position, like when it goes with carbon. When it goes with chlorine, it is first. When it goes with carbon, it is second, CH4, for example. When it goes with nitrogen, this is second, nitrogen first, NH3, right? So there are some, but when it goes to oxygen, it is first. So it behaves in different way, and know what, how, and why in your A-level classes. So if you consider potassium and oxygen, what is the valency number of potassium? It's 1. It's 1, the purple color. It's 1, right? Potassium has a requirement of 1 electron. And consider oxygen. Oxygen 2, that means oxygen requires 2 electrons. Potassium 1, oxygen 2. So if potassium 1 goes and give 1 electron to oxygen, one part will be completed. Oxygen, potassium. I will make potassium here. Potassium. There you got 2 electrons, 8 electrons, 2, 8, another 8 electrons, and the last energy level. So this one, potassium, 2 electrons, 8 electrons, 1, 2, 3, 4, 8 electrons, 8 electrons, and 1 electron, which is the valence electron ready to give. And the oxygen, when it comes to the oxygen, so it has oxygen, 2 electron, and then oxygen, another 1, 2, 3, 4. So oxygen is for 1, 2, 3, 4. So 5, 6. So this is the place where oxygen, this is the place where oxygen is in need of electron. So there are 2 places that oxygen needs 1 electron. Potassium goes there and fill this one. So the potassium's electron will be taken and will be filling that part. Then what about the other one? Then there should be another potassium. And another potassium comes over there and completes that one. So not sharing, it's exchanging. Potassium gives it, oxygen takes it. Potassium gives it, oxygen takes it. This is coming from potassium. So the result is the bond. So now see, potassium 1, oxygen 2. So I write the equation as how potassium should go to K2. Oxygen only receive, or 2 electrons should be received, so oxygen 1 atom is coming. So potassium will be making the bond as K2O. K2O. So they are ionic bonds because they exchange electron. Then what about hydrogen and chlorine? Hydrogen has 1 electron. Chlorine needs 1 electron. Very much possible to make a strong bond. But one thing is there. Yeah, hydrogen has 1 electron, correct. And hydrogen is very much willing to go for the noble gases configuration. Hydrogen, having 1 electron in its last energy level, 1 electron. In chlorine, very much ready, chlorine with 287. Look at here, hydrogen, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, and 7. Now, chlorine requires 1. Chlorine says hydrogen, hey, you have 1, give it to me. You have 1, give it to me. But the problem is hydrogen says I can give, then I don't have 1 anymore. At least I should have 1. Then hydrogen doesn't have anyone. When it gives this electron, if this electron is given to chlorine, what will have hydrogen? Nothing. So it is not possible. Hydrogen doesn't give it. Instead, giving that one, hydrogen propose, hey, I will be coming and to share electron with you. I'll be coming and will be sharing electron with you. So rather than giving and becoming 0, goes there and exchange electron or share electron. So that makes the covalent bond. This make covalent bond. Covalent bond, HCl, hydrogen chloride, right? Even though hydrogen is in the first group and it is being separated, you can see, because it's not ready to exchange electron with others. All the others exchange electron. So that's the whole story. And when it makes ionic bonds, the characteristics are different. Ionic bonds, high melting point, high boiling point. In aqueous solution, they can conduct electricity, right? There are some more characteristics, but when it is covalent bonds, they have separated characteristics. I don't know whether it is successful or not. I keep going on explaining everything. Any comment on that? Was it interesting or supportive?
Yes, sir. Yes, sir.
Good.
Very good.
Any other comments? Welcoming comments?
Sir, understood well.
Sorry?
Understood well.
Very well. And thank you for that. It is just like a lesson. And we were here, right? Write the groups of the periodic table. See that you did not ask, you did not request me to explain, but I personally myself explained it by spending my own wish. Write the groups of the periodic table which have atoms for exchanging electrons. So you can see donor 1, 2, 3, and recipients 4 and 5. Going to the next question. Question number 8. Question number 8. If a chemical bond, if a chemical bond is made with calcium and chlorine atoms. If a chemical bond is made with calcium and chlorine atoms. My first part. What type of bond is made? What type of bond is made? Second one, write the chemical formula. Third one, write two properties of it. Two properties of the bond. If a chemical bond is made with calcium and chlorine atoms, what type of bond is made? Write the chemical formula. Write two properties of the bond. Write the answer. Okay. What type of bond is made? The answer, what type of bond is made? What type of bond is made? What is your answer?
Ionic bond.
Ionic bond. Ionic bond. Ionic bond. Ionic bond. Write the chemical formula. Calcium and chlorine. What is the formula? Go.
CaCl2.
CaCl2. CaCl2 කියලා කිව්වේ. Calcium is in the second group. It has 2 electrons to be donated. Chlorine is in the 7th group. It requires 1 electron. So 1 calcium gives 1 electron to chlorine. So that's finished. Another electron is remaining in the calcium's valence electron. So that will be given for another chlorine. So CaCl2 is made in that way. And my next question, write the chemical formula. Write 2 properties of the bond. So what are the 2 properties? Ionic bonds. High
melting and boiling point.
high melting and boiling point. High melting and boiling point. The other one?
Conduct elixir in the fused or aqueous solution.
Conduct electricity. Conduct electricity in aqueous or fused condition. Fused condition. Fused means molten conditions, heated up to becoming a liquid. Another one, if you want another one, make, form Ca2 plus and Cl minus ions. Right. Write 2 properties. Going to the another question. This is 8. Went on with the 8th question and going to 9th question. Question number 9. Question number 9. Question number 9. Calcium can make ionic bond with. Calcium can make ionic bonds with a cluster, cluster, of atoms as well. Cluster of atoms as well. My question number 1. Write 2 examples for cluster of atoms which have the valency number 2. Valency number 2. Second, write 2 examples for cluster of atoms which have the valency number 2. Second, write the chemical formula for the above 2. Third one, write a cluster, write a cluster of atoms of which valency number is 1. 4. 1, 2, 3, 4. 1, 2, 3, 4. Write the above formula. Write the answer for them. I'll be back here within 1 second. cold outside. Very cold outside. Correct? Finish your writing.
Yes, sir.
So what are the answers? Write 2 examples for cluster of atoms which have the valency number 2. රන්දුනු නැතුව මට එක්කෙනෙක් කියන්නකො වෙන එක්කෙනෙක්. රන්දුනු නැතුව වෙන එක්කෙනෙක් කියන්න බා. Can anybody tell
Magnesium.
cluster of atoms, dear? Cluster of atoms කියලා කියන්නේ මොකක්ද? දැන් valency එක හදන්නේ එක්කෙනෙක් නෙමෙයි. දෙකක් atoms දෙකක් එකතු කරගෙන ඒ වගේ cluster of atoms 2 කියන්න බෑ. No idea. Cluster of atoms. So these are the clusters. Randunu. Example. No idea. මතක නැද්ද? අහලා නැද්ද? දැන් cluster of atoms කියලාත් අපි කියනවා මේකට radicals කියලාත් කියනවා. Radicals කියලාත් කියනවා. මොනවද? මෙන්න මේවා තමයි clusters of atoms. CO3 2 minus SO4 2 minus OH minus NH4 plus මතක නැද්ද? මතකද නැද්ද? තව තිබුණා නේද? commonly use කරන ඒවානේ ඔය තියෙන්නේ cluster of atoms. දැන් මට කියන්න මේ cluster of atoms වලින් calcium එක යන cluster of atom එක
CO3 to
ඔව් CO3 යන්න පුළුවන්. මම හොයන්නේ මේක කොහෙද තිබුණේ කියලා. කිවෙන පාඩමේ තිබුණේ?
third lesson.
Third lesson.
third lesson එකේ. third lesson. ඔය තියෙන්නේ. පොත දැන් කට පාඩම් කරවලා තියෙනවා මමනේ. ඔය තියෙන්නේ sodium chloride cluster of atoms. මේ තියෙන්නේ ඕන තරම්. Ammonium නේ. So you can see cluster of atoms, the lesson. SO4 2 minus PO4 3 yeah. The carbonate, bicarbonate. මෙතන මොකද එහෙනම් ලියන්න ඕන? Write the chemical formula valency. Write 2 examples for cluster of atoms which have the valency number 2 that can go with the calcium. So I will write CO3 2 minus SO4 2 minus. Write the chemical formula for the above 2. So we are writing that one. This should be blue in color. So you can have 2. CO3 because calcium's valency number is 2 and carbonate valency number is also 2. So when they make, it is CaCO3. SO4 2 minus, we can say is SCaSO4, calcium sulfate. Calcium's valency number is 2. SO4 2 minus, its valency number is also 2. When they exchange together, it is CaSO4. Write a cluster of atoms of which valency number is 1. So you get OH minus. So you can see 3 OH minus, and write the above formula. CaOH brackets 2. මෙන්න මේක හුඟ දෙනෙක් වරද ගන්න එක. ඇයි ඒ? දැන් අපි දැනගන්න ඕන මොකද්ද? කැල්සියම් එන්නේ ඉලෙක්ට්‍රෝන දෙකක් එයා දෙන්න. එයා මේ බලන්නකො. කැල්සියම් එන්නේ ඉලෙක්ට්‍රෝන දෙකක් එයා ඩොනේට් කරන්න. මෙතන එකයි මෙතන එකයි. ඒ දෙක එයා ඩොනේට් කරනවා. හැබැයි මැග්නීසියම් හයිඩ්‍රොක්සයිඩ් එන්නේ හයිඩ්‍රොක්සයිඩ් මේ OH එකම තමයි ඒ මුළු මේකටම තමයි ඉලෙක්ට්‍රෝන එකක් ඕන කරන්නේ. එකක් ඕන කරන්නේ. ඒ කියන්නේ මම මේක elaborate කරන්නම්. I will explain it only for this one, not many. Look at here. Oxygen. Oxygen's valence electron. Oxygen will get first 2 electrons, then 6 electrons. So they are long pair, one long pair, and valence electron for the bonding. So 1, 2, 3, 4, 5, 6. One is filled with hydrogen. One is filled with hydrogen. Now make OH. But one, see, here it is missing and looking for another electron. You will ask why oxygen does not go with another hydrogen. It goes and it makes H2O. H2O, but under the certain conditions, that OH remains by not sharing electron with another hydrogen. There are several reasons, and see, A-level class chemistry is waiting for your arrival if you are in grade 11 next year to be seated in the classroom and learn it, right? Then calcium. Calcium is ready very much with 2 electrons in its last energy level, right? Calcium has 2 electrons. So one OH comes and take this electron to its vacant place. And simultaneously, same time, another OH comes and takes the other one. So when I write the equation, I should write like this. Calcium, okay, calciums, that 2 electrons are shared with 2 OH clusters. That means Ca, 1 electron with 1 OH, Ca, another electron with another OH. And we write CaOH twice. If you write CaOH2, so then confused. What is it? What is this one? CaOH2, hydrogen, dekak oxygen. So this is complicated. The another importance of this one is the type of bonds available here. Types of bonds available. There are both types are available. Both types are available. That means ionic bonds are also there and the covalent bonds are also there. Ionic bonds come with ionic bonds. How? Calcium 2 plus with OH minus, 2 OH minus ions. And the covalent bonds, covalent bonds are there with OH. See, hydrogen oxygen, that bond is made with sharing electron. OH. So it's shared. And that's a covalent bond. When you say CaOH twice, the main bond that it makes is an ionic bond, but within that there is exchanging of electron, and that is covalent bond. Okay. Any comments up to now? You are happy about this one? Yeah. Shocked.
Yes, sir.
Yes, sir.
Then I think ඇඟේ ලේ වතුර වෙලා තියෙන්නේ නේද මේවා? I feel like it's too red. රතු පාට වැඩිද කොහෙද මම බැලුවේ? නේද? Because I had to change everything yesterday for my whole class. I took everything. මං හිතුවේ මාඩ මේ ක්ලාස් එක කරගන්නත් බැරි වෙයි කියලා. It's to yeah. ඔබ හිතන්නේ මේ ඉරිදා ක්ලාස් එක අවශ්‍යයිද? දැන් ඇතිද?
Tahu.
ඈ? නේ ඉස්කෝලේත් පටන් ගත්තනේ නේද? ඇද්ද? මදිද? කන්ටිනියු කරන්න ඕනේ. ඈ?
ඕනේ sir.
කරගෙන යන්න sir.
ඕනේ නැහැ. ඉතින් ඉරිදා දැන් ඉස්කෝලේ පටන් ගත්තනේ. නේද? හේතු දෙකක් ඕන මට ඕන කියන එකට. Two reasons. Recorded නෑ recorded. හේතු දෙකක් ඕන. අශිනියෝ. Okay. No reason means no class. 10.
So grade 10 lessons are reversed.
1. Where 10 lessons are being revised. Rather than sitting alone, you can see. So we have 10 and 10 to go. One reason, one more. Tenth question. කොච්චර ඉගෙන ගත්තත් එපා වෙන්නේ සයන්ස් නේ. එහෙමද? ඈ? සයන්ස් ඔව්. දැන් මෙහෙමයි. අපි අපි දැන් this is a kind of help, right? The other way around, kind of like I need to have now a new set of students for the next year. Now, grade 11s, you will be going from me once you sit for the exam. I will release you by end of December. So we will be starting new classes for grade 11 from January. Then the newcomers for grade 9. The grade 9 will be shifted to 10 and new students should be coming to 9. And then some more students as a kind of like extra sort of income. I would find out new children. It is your recommendation is worth rather than sending the advertisements and this one and that one. So once you recommend, hey, if you want to go with the real approach for science, I recommend so and so. So that is how you have to go. Because I have some policies that I strongly apply when finding new students. Very strong policies. I never use your names and I never use your photos. I never use your any sort of privacy for my promotion. And second one, I never use my college name. The school where I'm teaching now is not used for any sort of publicity. So I can tell that I'm working there and blah, blah, blah. So I can go for the higher demands. I don't do it. I never do it because this is something private. So my privacy is the same that your privacy or the institution's privacy. So I don't take it. And third, I don't criticize any sort of tutor in the field. So I don't go in criticizing somebody else's who teaches English medium sciences. No. So I took a little break. Can I go for the 10th question? You did not tell me the second reason. You only told me one reason.
Us.
Huh? Sir, Atu, your explanation is very clear. Huh?
අපි පවහින්ද
දේශාන් පුකුට කරනමගේ අපි පවහින්දල් අර බානු ඉන්සරි ලස්සන කමෙන්ට් එකක් දාලා තියෙනවා. So it's explaining is very clear. Your explanation is very clear and easy to understand. Nice. Yeah, my next question is, we are in I shifted the third one. 10th one. 8. Yeah, 10th. What could be the methane molecule? Nitrogen molecule. Aha, I got one. Following are some chemical compounds Following are some chemical compounds. Right. H2O, HCl, NH4, Ca, CO3, CaCO3, H2SO4, HNO3, MgSO4, MgSO4, Al2Cl3, FeO. Number one. Question number one. Write the formula. Write the formula which is written incorrectly. Explain the reason. Write the formula which is written incorrectly. Explain the reason. Do you have such a thing?
FEO.
Huh?
FEO.
FeO.
Al2Cl3.
Al2Cl3. Which one is the correct? Yeah. Al2Cl3 is a problem. FeO is correct because valency number of Fe is 2 because Fe2 plus ions it makes. Valency number of O is also 2. So that's correct. But Al2Cl3 is wrong. Al2Cl3. The reason? Chlorine Cl has the valency number. I will write. Valency number of Al is 3 and Cl is 1. Cl is 1. When Al2Cl3 is considered, Cl's valency number becomes 2, which is incorrect. Which is incorrect. So you can see that it is reciprocal AL, CL. So AL's valency number is given to CL, right? And CL's valency number is given to AL. So 2. 2 is wrong. AL3 is correct. Next question. Question number 2. Question number 2. Can you write Lewis structure for FeO? Explain. So give your reason. Give your reason. Give your reason. Can you write Lewis structure for FeO? Yeah or no? Asuka. Lewis structure කලියන්න පුළුවන් FeO වලට.
No, sir.
පුළුවන් ඇති සර්.
ඈ?
පුළුවන් ඇති සර් මම හිතන්නේ.
Where, sir?
P වල ඉලෙක්ට්‍රොනික කන්ෆිගරේෂන් එක මොකක්ද?
ඇයි බැරි මේ රඳුරු?
So ionic bond and
It is ionic bond. The Lewis structures are written only for the covalent bonds, right? So the answer is no. Reason is FeO is an ionic bond, right? Lewis structures are written only for the covalent bonds. Lewis structure is given only for covalent bonds. Right. Next one. Write the Lewis structure. Lewis structure for H2O NH4. H2O NH4. Lewis structure, Lewis dot cross diagram, Lewis dot and cross diagram, Lewis dot diagram, and Lewis structure. Is there anyone who want me to give a reminder or any explanations on this? මට ඒව තේරෙන්නේ නැහැ සර්. ඔය ලුයිස් ස්ට්‍රක්චර් එකයි ඩොට් ඩයග්‍රෑම් එකයි ඒ කියන එක තේරෙන්නේ නැහැ සර්. මට එක්ස්ප්ලেইন කරන්නකෝ. Is anyone here like that?
Yes, sir.
Anybody else? Anybody else? මේ බුද්ධිමයාගේ කටහඬ ඇහෙන්නෙම නෑ මට. බුද්ධිමා චින්ත. Right. I will tell one that what Lewis dot cross diagram, Lewis dot diagram, and Lewis structure. හරි. මෙන්න මේකයි කතාව. මේකට උත්තරයට එන්න ඉස්සර වෙලා. Lewis dot law. Lewis මොකක්ද ඒකේ මාතෘකාව අපි දාන්නේ? කොහොමද ඒක දාලා තියෙන බලන්න මට තප්පරේ. Dot and cross diagrams තියෙනවා. ඔව්. Diagram, the dot and cross diagram, Lewis dot diagram, Lewis structure are some of covalent molecules are given. මේ බලන්නකෝ. අපි Lewis structure එකක් ගැන හෝ dot cross diagram තුනක් තියෙනවා මේක. Covalent bonds can be represented එක dot diagram Lewis dot diagram Lewis dot cross diagram and Lewis structure. මෙතන අපි පාවිච්චි කරන්නේ Lewis dot diagram එකක dots. We use only the dots. Lewis dot cross වල අපි dot එකකුයි cross එකකුයි. Lewis structure එකකදී ඉරි කෑල්ලක්. Only a short line. How? Okay. When we are representing, we want to represent here the valence electron. Valence electrons are demonstrated. Valence electrons are demonstrated, not the other electrons, right? For the bonds, the bonds made by sharing can be represented as two dots. A dot and a cross. A short line for one pair. Important. The non-bonding electrons should be put as lone pairs in dots. The non-bonding electrons should be put as lone pairs in dots. Example. H2O. H2O හදන්නේ covalent bond එකක් මෙහෙම. කොහොමද? මෙහෙම. කොය. මෙහෙම මේ. Hydrogen. One valence electron. Oxygen. මේ two lone pairs තියෙනවා. Oxygen has two lone pairs. Two lone pairs. එතකොට bonding electrons තියෙනවා. Two lone pairs දෙක තියෙනවා bonding. that lone pairs ලා දෙන්නේ dot වලින් පෙන්නනවා. හැබැයි ඒ දෙන්නාගේ තියෙන ඉලෙක්ට්‍රෝන ප්‍රමාණය වැඩි නිසා polarity එකක් එනවා. එයාලා slightly negative වෙනවා. අනිත් අය පොඩ්ඩක් පල්ලහැට තල්ලු කරනවා. push downwards. මේ දෙන්න වෙනුවට අපි මේ රතු පාටින් දැන් මේ හයිඩ්‍රජන් ගෙන්න we can use either two dots dot and cross නැත්නම් ඉරක් බලමු H2O කොහටද ගියේ මෙතනනේ කොහෙද where were we? Where was it? Amitan. H2O. Balan. Hydrogen has only one valence electron. One valence electron. Oxygen has in return 1,6. May oxygen be. Two electrons are first one 1 2 3 4 then මෙන්න bond වෙන්න තියෙන electron එක මෙයයි එතකොට one hydrogen will be there to share that electron. Okay. And we'll be going to share with oxygen. And there should be another one. There should be another one. I'm going to take another one as here. The other one also goes there and share it as I showed you here. So you can have, no, I made a mistake. Yeah, you can have it, when it is shared, go in here. So now see, two long pairs. එනම් මම oxygen ලියද්දී ඒ two long pair එක ලියනවා අඳිනවා. Two long pairs. Oxygen. බිඳුවන මේ O. So this is one bond. If it is Lewis structure, you can have a short line and hydrogen. Another short line and hydrogen. And that is we call Lewis structure. Lewis structure. Lewis dot diagram. මේ short line එක වෙනුවට dot එකක් දාන්න. Oxygen long pair එක LONE lone pair මේ තියෙන්නේ. හයිඩ්‍රජන් ගේ එකයි ඔක්සිජන් ගේ එකයි. හයිඩ්‍රජන් ගේ එකයි ඔක්සිජන් ගේ එකයි. එහෙම නේද තියෙන්නේ? මං හරි නේද? ඊගාවට මේ ඩොට්ස් නේ. එතකොට ලුයිස් ඩොට් ඩයග්‍රෑම්. මේ තියෙන්නේ අනිත් එක. ලෝන් පෙයාර් වලට ඩොට්ස් දානවා. අර හයිඩ්‍රජන් ගේ එකට ක්‍රොස් එකක් දානවා. ඔක්සිජන් ගේ එකට ඩොට් එක දානවා. හයිඩ්‍රජන් ගේ එකට ක්‍රොස් එක දැම්ම ඩොට් එක දැම්ම. right. මේ තියෙන්නේ Lewis structure, Lewis dot diagram, Lewis dot cross diagram. How is it? Perfect?
Perfect, sir. Thank you,
Right.
sir.
And then go to our part. Write the Lewis structure for H2O. එනම් මම ලියනවා structure එකට oxygen එයාගේ තියෙනවා long pair 6 වෙනි group එක. මෙන්න එනවා structure එක hydrogen. hydrogen. ඇයි යාට පල්ලෙහා කරේ මෙයාලා slightly negative නේ. නිසා delta negative පල්ලෙහාට push කරා. NH4 nitrogen ඉන්නේ කීවෙනි group එකේද කියලා හොයනවා. nitrogen ඉන්නේ 5 වෙනි group එකේ. හරි එතකොට එහෙමනම් nitrogen ගේ තියෙන්න ඕන valence electron කීයක්ද? long pair එකක් තියෙනවා bonding electron 3ක් තියෙනවා. hydrogen යන්නේ මෙන්න මෙයත් එක්ක share කරගන්න. right like this. එහෙනම් මම ඒක අදිනවා. nitrogen 1 lone pair. Hydrogens 3. 1
So NH4 නේද?
sorry, NH3 වෙන්න ඕන මේක. I'm sorry. Not NH4. It should be NH3. 1 hydrogen. Not NH4. It should be NH3. ඇයි මේක පල්ලෙහාට මෙහෙම දාලා තියෙන්නේ? මෙයා delta negative. එතකොට මෙයාලා delta positive. delta negative එක මෙයා පහළට තල්ලු කරනවා. Okay?
සර් ඒවා මේ ඩිරෙක්ෂන් වලට ලියවට කමක් නැද්ද කියන්නේ? හරි
I
කෙලින් ලියවට කමක් නැද්ද H3?
දැන් ඔයාලගේ ටෙක්ස්ට් බුක් එකේ ඕක කෙලින් දාලා තියෙනවා. මම දන්නේ නැහැ ඒක අඳිද්දි එහෙම වුණාද කියලා. හැබැයි හරියට නම් එන්න ඕන මේ විදිහට. හරි ක්‍රමයට එන්න ඕන මේ විදිහට. ඒ කියන්නේ මෙයාගේ තියෙන මේ ඉලෙක්ට්‍රෝන නිසා එයා පහළට පුෂ් කරලා තියෙනවා. තේරුණාද? H2O දැන් මේක කීයටවත් මෙහෙම අපි අඳින්නේ නැහනේ. කොහොම දාලා සමහර අය මම දැකලා තියෙනවා මෙහෙම දානවා. මෙහෙම දානවා. කොහොම එක මෙහෙම දාලා මෙහෙම H. එහෙම ඉන්නේ නැහැ මේ බොන්ඩින් ඉලෙක්ට්‍රෝන මැදට දාලා මේ long pairs දෙක මැදට දාලා නැහැ නේ. long pairsලා එක පැත්තක තියෙනවා. bonding pairs එහෙම තියෙනවා. Okay? This is the exact correct method. All right, okay. How is the day? Superb?
Yes, sir.
Yes, sir.
Superb, sir.
Got new one? And time, yeah. Time to end up the session.